Okay, there is, in my book, I have a chapter on quantum consciousness, which is perhaps the most bizarre form of consciousness in all of science. According to the quantum theory, in order for something to exist, somebody has to look at it. Somebody has to make an observation. Before you think, in principle, it could exist in all possible states. When you look at it, it then assumes one state. Therefore, the observer, in some sense, determines existence. But observation requires consciousness. Conscious people make the observation. So the greatest paradox in all of science is the cat problem, the Schrödinger cat problem. If I have a cat in a box and I don't open the box, the cat could be either dead or alive. So how do we physicists describe a cat that you cannot observe? Well, we add the dead cat to the live cat. We add the two waves together. So the cat is neither dead nor alive until you open the box. Now Einstein thought, this is stupid. I mean, how can you be neither dead nor alive at the same time? Well, what can I say? Einstein was wrong. Electrons can be spin up or spin down. Electrons can be here or there at the same time. So this is the greatest paradox in all of science. How do you resolve the fact that you can have dead cats and live cats simultaneously exist in another state before you make the observation? And if you ever find the solution to this puzzle, tell me first.
The quantum theory is only controversial when you talk to philosophers, theologians, and the average person. To a physicist, it's accurate to 1 part in 10 billion. We can take an atom, shine a laser beam at it, and I can predict the properties to 1 part in 10 billion. The consequences are the internet, GPS, laser beams, computers, fiber optics, a broadband internet. All of that is a consequence of the quantum theory. Now, you'd think that a theory that powerful would be logical, compelling, and intuitive. Wrong. It is the most bizarre theory ever proposed in the history of science. Einstein couldn't get his head around it. It reduces everything to probability so that there's a probability that electrons can vanish, reappear someplace else. Electrons can be two places at the same time and exist in multiple states at the same time. Now, that's stupid. I mean, how can you possibly exist two places at the same time? How can you be in multiple states simultaneously? Well, get used to it. That's just the way the atomic world is. So why don't I vanish and reappear someplace else, like on Mars or the Moon? There is a probability that I'll do that. In fact, we give our PhD students at our college a question. Calculate the probability that you will vanish and wind up on the planet Mars. Give me a number. It turns out you have to wait longer than the lifetime of the universe for that to happen. But it's a calculable number. This is insane. This is absolutely counterintuitive. But the problem is, it's right. That's how our world is constructed. Our world is stranger than you realize at the atomic level. Now, we don't see it because we average out all these bizarre quantum effects. We're large objects. We consist of a lot of atoms. But at the atomic level, electrons exist in multiple states all the time. And you know what that's called? That's called the laser beam.
When I was a child, I had a role model, and I idolized Albert Einstein. And my favorite Einstein story is this. When Einstein was an old man, he was tired of giving the same talk over and over again. So one day his chauffeur came up to him, and the chauffeur said, "Professor, I'm really a part-time actor. I've heard your speech so many times, I've memorized it. So why don't we switch places? I will put on a mustache. I will put on a wig. I will be the great Einstein, and you can take a rest and be my chauffeur." Well, Einstein loved the joke, so they switched places. This went along famously until one day, A mathematician in the back asked a very difficult question. And Einstein thought, oh, the game is up. But then the chauffeur said, that question is so elementary that even my chauffeur here can answer it for you. Thank you very much. You've been a great audience.
Making contact with alien civilizations in outer space, how to deflect meteors, what happens when robots become super powerful. These are all subjects that we take in the second season. And, you know, some people ask me, well, why do this? And one thing is that I get to interview the world's top scientists in all these fields. So altogether, I've interviewed about 300 of the world's top scientists. So when I talk to them about the future, it's just not some science fiction writer just BSing about what he thinks the future is going to be. I'm talking to the scientists who are inventing the future in their laboratories. I have a front row seat to be able to get on the telephone, talk to Nobel laureates, directors of the major laboratories, and say, what is your dream? What do you think 2050, 2100 is going to look like? And to me, that's a thrill of a lifetime. Because instead of speculating, instead of moaning and groaning about when we're going to have flying cars, I can talk to the people who are inventing the future.
I've interviewed, about 500 scientists in my time for BBC television, for Science Channel. I have my own radio show, which goes out to 130 radio stations across the U.S. every weekend. And I always ask them the question, when did it start? When did you get interested in science? And they always say the same thing. When I was 10. When I was 10, it was a telescope, a microscope, a chemistry kit, a visit to the planetarium, an astronomy book. Something set them off. Because before 10, everything is mommy and daddy, mommy and daddy, mommy and daddy. After 10, kids begin to ask, what is beyond mommy and daddy? And then they get this existential shock, this epiphany, realizing how huge and glorious and splendorous the universe is. And then kids just eat it up. They want to know everything about physics and chemistry. They want to know why the sun shines. They want to know everything. And then they hit 15 and it's all over. What is the greatest destroyer of scientists known to science? The greatest destroyer of scientists is junior high school. You see, we're all born scientists. We're born wondering, where did I come from? Why does the sun shine? Why do the stars twinkle? We're born that way until we hit junior high school. And then it is crushed out of us. All of a sudden we have to memorize useless facts, figures that don't amount to anything. All of a sudden we're called nerds by our friends. All of a sudden it's hard to get a date. All of a sudden the hormones are kicking in. So it's difficult. And then in high school you have this pyramid. This pyramid where you have the beautiful people on top, the jocks and the cheerleaders. I have nothing against them, but there is a pyramid in high school, immortalized by Hollywood movies. But Hollywood never tells you that as soon as you graduate from high school, that pyramid turns upside down. They never tell you that. Look at Bill Gates, look at Steve Jobs, look at Mr. Zuckerberg. These are billionaires, leaders in innovation technology. They were at the bottom of the pyramid when they were in high school.
Now let's go into outer space. Everybody loves a starship. Some people say that flying saucers, flying saucers are impossible because the distances between two stars is too great for any UFO. Yet NASA is already looking into the possibility of building a starship. I know this because I had to review some proposals for NASA. So let's look at some of them. One is to build a sail, like a sailboat, in outer space. You put a laser beam on the moon. You shoot a laser beam to the sail. The sail is pushed by laser beam pressure, and you can reach near 50% the speed of light this way. This is one of the serious contenders to build the first starship. Another possibility is nanobots, microscopic little things that are then sent to moons. Now, if you saw the movie 2001, you realize that Arthur C. Clarke, who just passed away, was a visionary. He realized that if you are an advanced civilization, you're not going to send Captain Kirk on a starship, you're going to send a robot. This is a robot. The robot lands on the Earth and creates a copy of itself. Millions of copies of itself, and they shoot out, land on other planets, other moons, and they make a copy of themselves, more factories. Starting with one robot, you get 1,000. Starting with 1,000 robots, you get 1,000,000. Then 1,000,000,000. And pretty soon you have a sphere of robots expanding near the speed of light, colonizing all the moons, colonizing all the planets. That is the basis of the movie 2001. The movie 2001 is the most realistic encounter with extraterrestrial civilizations. If we ever meet an alien, probably it'll be a robot. A self-replicating robot left over from a passing civilization. This is my favorite, the ramjet fusion engine. It looks like an ice cream cone. It scoops hydrogen in the forward direction and burns it for fuel. This starship could last forever, because hydrogen is everywhere. This is my favorite proposal for a starship.
Okay, the question is Fukushima. How long are we going to experience the agony of 3 simultaneous meltdowns in northern Japan? We have the answer, 40 years. According to the utility, TEPCO, Tokyo Electric, it'll take about 40 years to begin the process of dismantling the reactor. And the accident is not over at all. A small earthquake, it'll send the accident starting all over again. You realize that the reactor is so radioactive, workers cannot even get in for more than just a few minutes at a time. They sent in robots. Robots are not smart enough to work in high radiation fields, total failure. In fact, the Pentagon, the US Pentagon, has made it a priority to create robots that can turn a screw, robots that can use a hammer, robots that can use a saw. We don't have those robots yet. And so the next thing they want to do is to insert cameras into the water to see where the melting is. It's so bad, we don't even have a picture. We don't even have a picture of the melted core. We know it's 100% melted. And the water, the radioactive water builds up. Swimming pools. When you visit Fukushima, you see all these swimming pools of radioactive water. The agony is unending. And so just remember that it will take 40 years to clean up that nuclear accident. So Japan, after World War II, made a Faustian bargain. Faust was the legendary figure who sold his soul to the devil for unlimited power. Japan said, we will go nuclear because we have no oil or coal, but there's a price. There is a price you have to pay, and that is you sell your soul to the devil.
How did the cosmos begin, and how will it end?
Well, we think the universe began with a cosmic explosion 13.7 billion years ago. We know that number to within 1% accuracy, in fact.
How do we know that?
Well, we know the rate at which the universe is expanding. Stars, for example, yellow light from stars is stretched because they're moving away from us, and they turn reddish as a consequence. That's called the Doppler shift. When a car moves toward you, for example, the frequency is high. When a car moves away from you, the frequency is stretched or lowered. It sounds like this. Now, you've heard that all your life. But what is that? That's a Doppler effect. It also works for light beams. When yellow light comes toward you, it's bluish. When yellow light moves away from you, it's reddish. The redder it is, the faster it moves. So it's trivial to calculate the expansion of the universe. You simply look at the night sky and see how much the light is redshifted. Then you run the videotape backwards. We have this enormous, quote, videotape on computer of the expanding universe, so we run it backwards. You've all seen explosions run backwards on television. And then you get back to the point where the universe was a small little dot. That's how we know the universe began, with a fiery explosion. And we can also pick up the afterglow of the Big Bang. When you get a radio and you turn it between stations, you get that static, that static. Believe it or not, a few percent of that static comes from the Big Bang itself. You were actually listening to Genesis on your radio. Your television set, when you have snow on your TV set, a few percent of that snow comes from the creation of the universe. More percent comes from planet Jupiter. Planet Jupiter also causes static on the Earth, which is more than the Big Bang. But we physicists have measured that microwave background radiation. We now have baby pictures of the infant universe. And you know what? It's an explosion. We have baby pictures of the explosion itself. And sure enough, it is a gigantic explosion, just like everyone thought. And we've actually not taken pictures of it in the microwave region. The big question is, how will the universe end? There are two ways it could end, in fire or ice. If it ends in ice, the universe keeps on expanding and gets colder and colder and colder. Or the universe could expand, stop, and then come back and get hotter and hotter and hotter in the big crunch. Either way, the laws of physics say we're doomed. Either we're going to die in fire or die in ice. But there's one way out of this death. The question is, the laws of physics, are they a death warrant for all intelligent life? Most physicists would say yes, that inherent within physics is a death warrant for all intelligent life in the universe, because either the universe dies in ice as it expands or dies in fire as it contracts. I think there's a loophole. The loophole is that billions, trillions of years from now we'll be so advanced that as the universe dies, we will leave the universe. We will leave our bubble, have a lifeboat, and then go to another neighboring bubble and start all over again. So in other words, this theory of everything may ultimately be the theory of salvation for intelligent life in the universe. Now that's speculation, but in parallel worlds, I even give you the blueprint, the design, how much energy it would take to build a machine which would take us to a neighboring universe.
I must disagree with my esteemed colleague here. Okay?
Except
First
for the
of all,
esteemed
let
part.
me say that science is the engine of prosperity. From steam power to electricity to the laser to the transistor to the computer.
That's not true.
We're
That's
talking
technology.
about, hey,
It's technology.
can I have my say? Okay, sure. You had your say. Let me have my say.
Yes.
However, the information revolution has a weakness, and the weakness is precisely the educational system. The United States has the worst educational system known to science. Our graduates compete regularly at the level of third world countries. So how come the scientific establishment of the United States doesn't collapse? If we're producing a generation of dummies, if the stupid index of America keeps rising every year, just watch network television and reality shows, right? How come the scientific establishment of the United States doesn't collapse? Let me tell you something. Some of you may not know this. America has a secret weapon. That secret weapon is the H-1B. Without the H-1B, the scientific establishment of this country would collapse. Forget about Google. Forget about Silicon Valley. There would be no Silicon Valley without the H-1B. And you know what the H-1B is? It's the genius visa, okay? You realize that in the United States, 50% of all PhD candidates are foreign-born. At my system, one of the biggest in the United States, 100% of the PhD candidates are foreign-born. The United States is a magnet sucking up all the brains of the world, but now the brains are going back.
Right.
They're going back to China. They're going back to India. And people are saying, oh my God, there's a Silicon Valley in India now. Oh my God, there's a Silicon Valley in China. Duh. Where did it come from? It came from the United States. So don't tell me that science isn't the engine of prosperity. You remove the H-1B visa and you collapse the economy. In Wall Street Journal, editorialized against a congressman who wanted to ban the H-1B, saying they'll take jobs away from the American people. The Wall Street Journal said, look, there are no Americans who can take these jobs. These are at the highest level of high technology. They don't take away jobs from Americans. They create entire industries. And so that's why we have an Achilles heel, and that's the educational system. And again, sociology majors are not necessarily going to be the ones determining the future of Silicon Valley, but physicists, engineers. We need more of them, not less.
Parallel worlds, you discussed time travel. Is it possible?
It could very well be possible. Stephen Hawking has said that, yes, time travel is possible, but not practical. In other words, don't expect an inventor to create a time machine in their basement today. We're talking about the energy of a star, the energy of a black hole. But in principle, if you could master that energy, then you might be able to bend time into a pretzel. The mathematics says so. Even Albert Einstein realized in 1949 his own equations allow you to go backwards in time. If the universe rotated, for example, a very simple kind of universe, a rotating universe, and you go with the flow, you go around the universe as it rotates, you can come back into the past. So simply walking around a circle, you come back not where you left, but you come back yesterday. So even Einstein realized, oh my God, his own equations allow for time travel. So in his memoirs, of course, Einstein had to address the question, is time travel possible? And he said, aha, I have found a loophole. And that is, the universe expands. It doesn't rotate. So it means that if the universe rotated, time travel would become commonplace. So thank goodness the universe expands.